Hello, everybody, for this virtual edition of Kotlin Office Hours. I'm Erik Christensen, and I wrote a library which I'm going to talk to you about. So Island Time is actually I should say a little bit about me. So I'm a senior developer at a part of Siemens that works on 3D CAD software. I work on the NX CAD system. Professionally, I do a lot of C++ development. So everything that I'm talking about here is very much extracurricular and kind of on the side. So moving on. So Island Time is a library for working with dates and times in Kotlin. It's heavily inspired by the Java time library and provides many of the same features. So that kind of begs the question, why? Why would you write another time library? And I guess to make a better wheel. But really, though, the number one reason is multi-platform. We'd also kind of like to be able to capitalize on some of the features of the Kotlin language. And did I mention multi-platform? Let's point out that this was not actually a better wheel. This is a real attempt at a car. It's called the Dynasphere from the 1930s. It had apparently a lot of issues with braking and turning. It looks incredibly cool, though. I'm sure it'd be really fun to ride around with, ignoring those other details. So that's a little bit of just a primer on Kotlin multi-platform in case people are not totally familiar. Maybe you didn't see Kotlin everywhere. Kotlin may be best known as a JVM compatible language, but Kotlin code can also be transpiled into JavaScript or compiled into native code, allowing it to run almost anywhere. So one of the more exciting use cases is for code sharing between Android and iOS apps. And this is kind of what Island Time's focused on, although the JVM will also work too. So you could use it on server side. So one of the big challenges with multi-platform code here is that you can't use directly a lot of the platform libraries that you might be familiar with. So like the Java time library just doesn't exist on your iPhone or retrofit or anything else you might be familiar with as like an Android developer. So date and time functionality is usually pretty universal across different kinds of platforms and libraries, but there are a number of differences in the APIs and capabilities. So if we take kind of, I guess, a little bit of a look at date and time functionality across like kind of a subset of platforms and languages. So on Java, we have a lot of these old Java util and Java text APIs for working with dates and times, some of which are now kind of deprecated. We have the newer Java time library, and there's also a 3.10 backport that kind of brings that to before JDK 8. Then you have a number of different third-party options. The ICU for Java has a lot of better ways of doing some kinds of like date formatting that go beyond a lot of what you can accomplish with the platform libraries itself. And then you have Jota time, kind of the predecessor of Java time and time4j. On Android, you have kind of more or less the same sort of things as Java. I mean, it's JVM compatible. You can generally use Java libraries. There are some additional APIs in Android text, such as date utils, which actually seem to kind of wrap some of the stuff that you have in the ICU, even for formatting. And they also started including the ICU kind of repackaged under this Android ICU namespace starting in API 24. Kind of another exciting little development there. So there's also a desugared version of the Java time library that's available starting in Android Studio 4.0 or Android Gradle plugin 4.0, I guess more accurately. So you will be able to directly use Java time on the pre-API 26 devices pretty soon. It's already in beta right now. I've played around with it a bit kind of myself, and it has its own set of, I guess, kind of quirks, kind of like the 3.10 backport. They're kind of like best efforts of trying to implement this new API with what you have on the old devices. So there's their own kind of idiosyncrasies. So, and on Apple, they have a bunch of foundation APIs that deal with dates and formatting, and there are also third-party options like SwiftDate that try to make some of that a little bit nicer. JavaScript has a built-in date class and has some functionality in the INTL that does a lot of things for like time zones and stuff. Its capabilities are a little limited, but improving. And then there's a lot of third-party libraries available. Moment's a big one that's used a lot, and Luxon, others. C++ 20 actually has a brand new date and time library that's going to be available soon on a variety of platforms. So that's something that you could easily wrap in a C API and then call from Kotlin. So that it's an option for development. You have lots of old C functions and POSIX. So basically, I could just go on, but I think you get the point. There's a lot of different kind of libraries out there, and a lot of these are available on all the different platforms that you can target with Kotlin, but they're not directly exposed in Kotlin. So you have to kind of work to be able to have a nice API into it. So kind of leads us into design goals for this library. So with Island Time, we're kind of trying to bring powerful date and time functionality to Kotlin Multiplatform, primarily enabling code reuse between Android and iOS. Try to draw heavily from the Java time library and other more modern libraries, kind of to mitigate risk and avoid reinventing the wheel badly. There's a lot of thought that went into the development of the Java time library, and it is definitely one of the better ones as far as overall capabilities and thought that kind of went in there. We also want to kind of take advantage of Kotlin features, but we also want to try to allow a lot of existing Java time code to be converted easily. A lot of people, including yourselves, probably have a lot of Java code that you want to be able to make into platform. So being able to do that is kind of a good thing. Ultimately, the hope is that you can use some like deprecation facilities to do automatic conversions in the IntelliJ IDE wherever possible to help kind of facilitate that. So while Island Time does draw heavily from the design of the Java time library, there are some important differences. It's a little bit more extension-oriented than pure kind of object-oriented. This means it's a lot more kind of functional, relies on extension functions. It tends to lead to improved IDE friendliness and overall some fewer opportunities for runtime failure. It follows Kotlin conventions instead of Java. We take advantage of properties, lambdas, infix functions, all of those fun things. And we use inline classes to provide type-safe durations with little to no overhead. There's also built-in support for date ranges and time intervals because those are part of the Kotlin language. And we do have some caveats too. So I got coronavirus. It's ISO calendar system only. There's no support for custom formats yet without tapping into some platform-specific code. You got no like week gears and quarters, and well, basically it can't quite do everything that Java time can do. It's not all exposed, at least through common code. You can always convert between different types. So we're gonna kind of look at a little bit of code. I don't know if there are any questions so far. Can anyone hear me?
Yes.
Yes.
Oh, good.
No questions.
All right. That's good. All right. So in this example, I kind of got here. So I'm building a zoned date time. So I'm kind of assuming a little bit of familiarity with the Java time library here. So examples of how you do some things in both. So in Java time, we can say like local date.now. We can say at time to create a local date time out of my local date. And then I can say at zone to create zone date time. That's kind of a pattern there. In island time, you have kind of a similar pattern, except we use the at as like an infix operator, so that you can use that to be able to kind of combine together these different smaller parts of a date into like bigger kind of like date components. If we wanted to add a week, instead of having plus weeks, we have operator functions available, so we can use one.weeks with a property on integer that creates a weeks type, so that we can uniquely identify the different types. We'll talk more about durations a little bit later. So now if we wanted to change a time zone in Java time library, there's like two different ways you could do that. So you can use this with zone same instant that tries to keep the instant the same but change the time zone to something else. Or we have zone same local, which is basically just copying my local date time component and then changing the zone and offset to match that. In island time, you kind of have the same sort of thing, except we have a little bit different operators available for this. So adjusted to is what we use to be able to change the time zone on an existing zone date time. And then we have this copy function that kind of mimics what the copy function that you have in like data classes that allow you to kind of take any component of your date and time and replace it, and then have well, a copy of it, so that you can kind of copy the date and time part. So in the process of changing the time zone, the offset would automatically get updated to something that's actually valid within that time zone. There's a little bit of a trickier case. So in the Java time library, if I want to get the next Wednesday, I have to use these things called temporal adjusters, which I don't know if other people have used before, but it's kind of this generic way of having things that you can use to look at different properties of your date and time, and then try to do, well, whatever operation you want. It's a very generic kind of mechanism. So if you wanted to be able to like actually use this, just like looking in the editor, kind of like good luck, because you have to know that there's this with function that can take this temporal adjuster type, and then you have to kind of find the temporal adjusters class that contains a bucket of these different things that you can use to do it. So there's several levels kind of indirection involved in being able to get there. So you probably have to make a trip to Stack Overflow. With Kotlin, we have extension functions. So when you do this in island time, you can just type into the IDE and you get something that makes a little bit more sense or presents itself as kind of an option. So there's a little bit less indirection to get to the kind of operation that you want to go to. And this is also the case if we want to say like at the start of the week. So in the Java time library, there's this week fields class that you have to actually construct, but it is a temporal adjuster that you can use with, but again, there's a few levels of indirection there. So you have to create this week fields using like locale if you wanted to get the local start of the week, because the day that the week starts on can kind of change. It could be Monday, it could be Sunday, like here in the US, or it could be Saturday in some places. So to be able to get the local day of the week, you'd have to kind of go through that. Island time makes it a little bit easier, again, using extension functions, and the week settings accomplishes the same thing of being able to get the system settings for you. Island time's week settings also, I'll just note, they respect the system calendar settings, because sometimes the calendar settings can actually differ from the locale settings on some platforms, like on Apple. So if you have like iOS and Mac, you can actually change that independent of locale. So that's kind of some of the sorts of details that it tries to also kind of address that make concessions to other platforms. So it's easy enough to convert between the Java types and island time types, since they largely mirror each other. So you can go to Java local date from a date. You can go to island date from a Java local date. You can convert a Java to a Java duration to an island duration. It's all pretty straightforward to do. The same kind of goes with the Apple platform types. So on Apple systems, as part of their platform APIs, you have NSDate, which is kind of like an instant, and you have NSDate components that separates out the calendar and time components. So it's sort of like date, time, zone date, time, and all of those. It's just not quite as far in the kind of type safety direction. It's a little bit more kind of generic. So by default, island time kind of preserves the units that are associated with a duration, like months or minutes, restricting the set of the available conversions to the ones that actually make sense. So I can say on a date object, I can get the days that have happened since the Unix epoch of January 1st, 1970, and then I can say in milliseconds and convert that into a number of milliseconds since 1970. And then I can take the value of it and call some external API that expects the value. It can all be done in kind of a type-safe manner. Any of the conversions that you'd be able to do from days would only be conversions that actually make sense for a day's type, for example. You can also do like arithmetic with the different kinds of duration types wherever it makes sense to do so. That means that like months and days you can't add to each other directly because months have potentially varying numbers of days because it's a calendar unit. So there's handling for calendar units and versus time units. So when you combine units that can be combined, generally the smallest unit is preserved. You can also break any of these duration units down into any of their components with any combination of bigger units. So if I have this period of 5,689 months, I can break it down into the number of decades, years, and months that all compose it as part of the API. I can also take any individual unit and then convert it into kind of a generalized duration, which is similar to what you have in the Java time library. And that's capable of representing basically insanely big durations. When I say insanely big, I mean like bigger than the known age of the universe at nanosecond precision. That's very, very big. So you always have some possibility of overflow whenever you're working with any unit individually, but as soon as you start representing it with a duration object, you can handle some pretty big time periods safely and not have to worry about any possibility of that happening. There are also periods, which is a date-based duration in the Java time library. So period class largely mirrors the one that's in Java. And that lets you just kind of combine different calendar units together. So you can have years, months, and days that are all kind of grouped in as one. Now we get to ranges. So in Kotlin, ranges are built into the language, and island time takes advantage of them. So in island time, a date range is an inclusive range of dates that implements Kotlin's closed range interface. So I can use the range to operator that's a part of Kotlin, the ... and I can create a range between two different dates that way that's inclusive. Or I can use the until infix operator that's widely used too, with like integers or whatever else in there, and get an exclusive end to my range. So once I have a date range, I can call different functions on it that make sense for dates. Like I can do random and get a random date within that range. I can get the length in days. I can get weeks, years with any individual unit. I can convert it into a period. I can also, from an individual date, I have a week range operator. So we mentioned start of week a little bit earlier. So I can take the week range and quickly get a range of dates that matches that of the localized week. And a little bit of a departure from Kotlin's ranges, island time's ranges actually can be unbounded instead of just empty. So you can have an end or a beginning or both that are just infinity, basically. So that could be very useful if you have an unspecified end date or just need to be able to represent something that's in effect from, say, now until forever. So we can also iterate over date ranges. So a date range is a progression, and you can also, so by default, you can kind of go through date by date over a range. So I say, like, if we're date in today, from 1 month ago until today, and then do whatever I want there. But alternatively, I can also specify a step, which my step could be a different number of days. It could be weeks, months, it could be years. And then I can kind of step over a period of dates at any increment that I want to. So time intervals. Unlike date ranges, time intervals are half open with an exclusive end. And this is to help avoid some kind of weird behavior. So with dates, there's kind of a natural unit of a day, but when you start expressing time, it becomes a question of the granularity at which you measure time. So you have in a lot of different cases, like island time can represent times kind of like Java down to the nanosecond. But there are a lot of places where you might be restricted to millisecond precision or microsecond or whatever. So once you start trying to represent times with an inclusive end, it gets a little bit gnarly trying to manage possible precision differences. So you kind of avoid doing that, even though that means it doesn't directly implement Kotlin's closed range. So there's several different representations for time intervals that kind of match the different types that you have available in the Java time library or in island time. So date time, you have two date, you have a date and a time in just an unspecified place. There's no particular offset. With an instant interval, it's basically a period of time between two timestamps. No knowledge about the local time or care. Offset date time interval, I'm able to, in this example here, this is actually the transition between standard and daylight savings time here in the East Coast. So if I was on March 9th, it would be standard time with an offset of -5. And then the next day, it's an offset of -4 hours from UTC. So I can capture the local time difference, even though the offset changed, while still being able to know the exact instant. And then with the zone date time interval, kind of taking that a step further in that I have the full time zone associated with it. So in this example here, like back in the day when people were actually able to fly out airplanes to places, maybe you had a flight that left New York and landed in London, and you wanted to be able to represent the start and end as part of your interval, you can do that. So inclusivity within a time interval is based on the instance that define the start and the endpoints. So that means that the timeline order is what's important and not the natural order. And that's actually kind of an important consideration for the offset date time interval and zone date time, because they have differing offsets. So an offset date time, for example, if you might have multiple ways of representing the same instant in time where you have different offsets. And those different ways of representing that same instant are not necessarily equal because they have different offsets. And if you were using them in some kind of a sorted container, you wouldn't necessarily want them to just arbitrarily get put in random places. You might want some kind of consistency. That'd be like a natural order. So in the Java time library, those are actually considered to be comparable, the interface comparable, so that you can compare them to each other, but they don't compare automatically by timeline order. And that's actually problematic if you use them in, say, Kotlin's closed range, which is assuming that these types are comparable in a way that kind of makes sense. So to kind of illustrate that, like if I had a zone date time and I create one from now until a day from now, even if I take that same date time and I adjust it to a different time zone, it should be considered to be inside the interval. And depending on offset differences, that might not necessarily be true if we had implemented comparable or used it in the same kind of way as what the Java time library does. So only instant interval allows iteration, though the other types can be converted. Unlike date ranges, a step is necessary to create a progression. There's not really a logical increment to have by default, like a single day. And you probably don't really want to step over things in increments of nanoseconds. So you have to specify a step explicitly, but then you can go through an entire range of instance at whatever kind of step you want. Parsing. So by default, IslandTime reads and writes all dates in the ISO 8601 format that matches what you get with Java time. And that's kind of the international standard and a good way of working. We have additional parsers that are also included for other ISO formats as part of the library. In an ideal world, non-ISO formats wouldn't exist, but sometimes they do, and you need to parse them. So to support that, you can define custom parsers using a DSL. So in this example here, I'm able to say that there's a month, day, and year American style date that's in this kind of format with slashes separating it, and I can write this parser that can parse that. I could also accommodate some variations when I define that parser by using any of or optional as part of it. There are a lot of other kinds of things here that you can also do to control it. So there's definitely some of these things that are kind of tailored a little bit more to parsing. So there's not a complete kind of duality between what you would do for parsing versus formatting per se, to give you just a little bit more kind of wiggle room when you're writing parsers. And there's also a notion of grouped parsers, and that's mostly just to deal with the ranges. So if you have multiple items that have like the same kind of fields associated with them, you have a way of grouping those inputs. And the nice thing about being able to have a group parser like this is that you can have child parsers that reuse your other parsers that might parse individual items as part of it. So by having this kind of DSL sort of structure like this, you can create parsers that are and elements of parsers that are entirely composable and reusable. Localization. So different cultures have different ways of writing dates and times, even when you take language out of the equation. So we're the weird ones who have the month before the day and then the year usually when we write our dates, but a lot of other people put the day before the month, and the international standard is to put the year first. So there's a lot of different ways you can write a date or a time. As I think probably a lot of you already know, localization in general is pretty complex and can be hard to get right. And there is no multi-platform locale in Kotlin yet, but each platform does have APIs for formatting dates and times. So if we kind of just take a look at some of the APIs for Java and on Apple here, we see here that in this example, this is actually, they're pretty similar to each other. So if we want to be able to kind of render a localized date and time, we can say, do we want a full style, a short, medium, or long? So here we're just picking the full style for both the date and the time for whatever it gives us. Let's just let's see what this date and time look like when we use the formatter. And you'll see that if I actually run this code across a bunch of different platforms, I actually get different results, even though it's a lot of the cases here, or actually all the cases here where they're different, you're actually using the same API. So on Android API 29, on my Mac on the JVM, or on my iOS simulator, I'm getting this at kind of inserted in the middle. When I run on Android API 29 using the 310 backport, I don't have an at, and I also don't have an at when I'm running the desugared version of the Java time library that's available in Android Studio 4.0. versus I do when it's just using Java time directly. So that's kind of interesting. And then on my Windows machine, I don't even get the Eastern Standard Time at all. So clearly there can be differences even when you're using the same API call. And this is just a pretty basic case when we're looking at English, like the most common language, and not like right to left text or anything kind of funky going on with it. So under the hood, every platform nowadays draws this localization data from the Unicode CLDR, which is the Common Language Data Repository. So each platform and version of that platform may expose the data differently, and very likely you'll have different versions of the underlying data as well. So packaging some of that data as part of your application is an option. That also would require additional disk space, care about how you load it into memory, what kind of mechanism you want to do. It could be a lot of data. So do you want to do that on demand, lazily? It's on you to keep updating the data. So when you use platform APIs to do all that, a lot of those kind of considerations are kind of taken care of for you. If you absolutely need consistency, then you have a little bit more work to do for yourself. So Island Time tries to do kind of the best that it can with the platform data, but it does offer the flexibility to write your own provider and do things differently, which could be very useful too if you had some kind of edge case or whatever where you just needed to hack something. You could copy the provider that it has and change something around so that you get different text in a different situation. So there's kind of two interfaces right now. There'll probably be another one coming soon, but there's a date time text provider and a time zone text provider kind of available. So one gets date and time fields like month names and days of weeks. Another one gets the localized names of the time zones. So currently, Island Time can't convert dates to localized formats without turning to platform-specific code like I was showing in kind of a few slides ago. But you can access and parse, if you want to, localized text. So I can call this like a localized name function on the time zone, month, day of week, and be able to get that whatever that text is and whatever format I'd like. There's also a display name function on all of these that has kind of a fallback to something else if the text can't be found, because there's no guarantee that text in a certain format will actually be available on a certain platform. So there is a little bit of an elephant in the room, and that is the Kotlin X time. So JetBrains announced that they're working on their own multi-platform time library at KotlinConf back in December. It's not available yet, and it's not really clear what it'll look like, though the duration class that was added recently to the standard library and rumor mill seem to suggest that it may be something a little bit closer to the Apple platform library than Java time library, but I'm really just speculating. I can say, though, that if we look at the Kotlin duration class, that it is a little bit different from the one that's in the Java time library. So Kotlin's duration is just a double that represents a number of seconds. And well, using a floating point to represent durations is not unheard of. That's actually what Apple does in their APIs, but it can lead to some like head-scratching kind of situations and test failures depending on what you're doing. So in this example here, I'm using Kotlin time, and if I take 1 second and I add 1 millisecond to it, it's not equal to 1 second and 1 millisecond. So it's just, you get into a little bit of the oddities that can kind of come about from using floating point. Again, kind of really depending on what you're doing. Island time, kind of like Java time library, has a fixed nanosecond precision across the entire time scale. And it also uses checked arithmetic so that anytime that there's overflow, it fails hard. It gives you an exception instead of silently failing. So does that matter? I mean, it all depends. It's a distinction. There are, I guess, merits to using floating point. It's very popular in game engines and for things there, but there are definitely issues that you can run into with the accuracy, just depending on what you're doing. You can get compounding error, especially if you're mixing large durations with small ones. Like say you had a number of seconds since the Unix epoch in 1970. Well, that's quite a few years ago right now. So if you start adding that number to a bunch of smaller quantities, you can lose precision, and then maybe that creates a problem. Maybe it doesn't. Maybe it ends up still not being too relevant for your application. it really all depends, but it kind of is a difference. Another thing that is kind of noteworthy is that Kotlin also defined a days property on the integer that kind of converts days into a 24-hour duration. And that also is kind of a little bit of a different way of working than, I guess, what Island Time does, where it kind of preserves unit granularity. So in Island Time, you can kind of distinguish between like a conceptual day and a 24-hour duration, whereas Kotlin kind of forces a 24-hour duration on you, which isn't always what you want. If I had a zoned date time object and I added a day to it, and it was say, if it was say 2 o'clock today and I add a day, and even if the time is changing tonight from daylight savings to not daylight savings, I would expect to see the same hour when I add a day. So that's where the difference kind of comes about between the conceptual time and an actual like exact time, like a duration. So future directions, well, I guess we'll see what happens with the Kotlin X time. But in the meantime, I've been working on a number of improvements. Some other ones are in the pipeline. So I have a GitHub Pages site with expanded documentation and API reference. Support for localized date time patterns and templates should be coming soon, along with formatting for custom fixed formats. Some improvements to the durations, kind of in prototyping, some ways of combining the calendar-based units and time-based units together, and potential changes to behavior there. And also some improvements to the intervals. I'd like to have a bunch of operators like union and intersect, so that you can kind of combine different intervals and do a bunch of other fun stuff with those. And with that, I guess that's kind of a wrap. So Island Time brings a lot of useful date and time functionality to Kotlin Multiplatform, and it's available today. And
thank you. This was a great presentation.
Yeah, really hard to applaud.
You put a considerable amount of work in this multi-platform library, I must say. It's really impressive. I can't wait to try it out, actually. How does it stack up? Are there any other multi-platform time libraries out there on the Kotlin language? Or is this, besides the effort that JetBrains put into it?
There is Clock, K-L-O-C-K.
Yeah.
I have seen another one that somebody else wrote too. I think it's called Fluid Time, but I don't think that either of them are nearly as capable. Clock does have some formatting built in, but it's I think it's like hard coded.
Let me jump in here so I can talk shit about the other libraries for you. that way you don't have to trash them.
Yeah, talking.
So this is Kevin. I'm in New York. So I actually, first I want to say, like, I did also port Java 8, but like directly to Kotlin, and I got it to functional, and then we started talking, and this is an amazing amount of work you've done. I just want to say that, like, knowing, like, I was at the very, very basic prototype level of what you sort of accomplished here, which is amazing. It's a lot of effort. Clock didn't have a prototype from which I could see that its design came. Whereas like starting with Java 8 and other things and building on top of them makes sense. Starting from your own without a distinct predecessor is, and as it's an individual who wrote it, and not that that person is bad, it's highly ambitious, and the burden of proof is on you to prove that what you've written, especially a date time library, is super functional and precise. And like when I first looked at it, especially, there was very few tests. There was no time zone understanding, like none of that stuff. So Clock's always been kind of suspicious, but it's been the only one that's been available. So I think it got a lot of traction because of that. The other one I know what you're talking about, I've never, beyond barely looking at it, and I don't think there's a lot of traction with that either. Like, I think that outside of JetBrains, at this point, yours is almost certainly the most functional. but not the most known. Clock's more known just because it was like the first.
So we need to publish this one a little more. Put it out there. Put some ads on Twitter.
Yeah. Yeah, I would also. I mean, you should talk to Roman from JetBrains, and you know, they said that they were working on it, but they also changed the focus quite a bit. So even if it's just to talk to their design team to get involved, or maybe it's on hold and they're working on something else. Who knows? So they're pretty open about that stuff.
Definitely could consider that.
Because I'm especially amazed at how much functionality you put in your library right now. Because daytime, a lot of people make the mistake that it's easy. And it's not. It's absolutely not easy with all the things you have to take into account. And yeah, so with the ranges and the durations, which is very hard given all the time zone arithmetic that's going on. It's impressive.
Yeah. Yeah, it doesn't, I mean, I guess by only doing the ISO calendar system, which is basically Gregorian taken to eternity, it does kind of simplify things a little bit, but I mean, for most people, like, that's kind of all you need. It's
Well,
really pretty universal.
I would say I did talk to the date person from JetBrains that was working on it, and I think they're doing the same thing, and I think the desugaring in Android also does the same thing. Like, I don't think they're doing anything that's not ISO, at least at this point. So, you know, it's you're not like the other calendar systems. I mean, not that people don't use them, but they're, you know, it's not exactly something to focus on out of the gate, I would say.
I was curious if you could speak a bit to like the time zone handling. I remember we had a conversation a while ago about like where the time zone database stuff comes from and like how you handle that multi-platform.
Mm-hmm. Yeah, sure. So yeah, time zone database. So the kind of the standard for time zone databases is IANA, their time zone database, and so they kind of manage this time zone database that has a bunch of different region codes that look like the ones you saw, like America, New York, and Europe, London, and so on and so forth, all these identifiers. That they come out with usually a few revisions of that every year. And basically every platform is using that nowadays. Windows does have actually kind of its own scheme, and there's a way to adapt between the old Windows way and the newer IANA way, sort of. But basically they all have that data. So it then becomes kind of just a question of like, how do you access that data? So I guess on Apple, like you can use their platform APIs to kind of with what they've exposed through their platform APIs to kind of reconstruct enough information to be able to get functionality that's kind of similar to what you can do with Java. And then obviously if you have the Java time library available, well, you can use that because it is a platform API that's available on your system. So Allen doesn't like replace the Java time library, because under the hood you still kind of need it, because that is the platform API that's usually exposed for accessing things. I guess the desugaring and all like that makes my life easier, because there are fewer APIs that I have to worry about calling into and different potential like incompatibilities for the most part. But actually, it looks like the desugared API will work a little bit differently under the hood. So it looks like they're actually calling into like the time zone class that they have in there, and I think that on Android they do have. I think they are drawing from ICU stuff for a lot of the things that they're exposing. But basically, with the provider, though, so that you can, so that by default it uses the platform data, but you can also write your own provider if you wanted to. You could take the database, package it with your application, and write something that'll load it into Island Time if you really wanted to go through that exercise.
I have a quick question. Which platforms do you support right now in your multi-platform library?
So you got JVM, Android, iOS, watchOS, tvOS. No JavaScript or any of the other native ones yet, anyway.
I had a
Was it
question.
macOS? Really quick.
Not too long ago, I ran into an issue. I was using a car sharing app, and I rented before the daylight savings time change, and the rental date was after the change, and it was an hour earlier than it was supposed to be. Does Island Time have anything to handle that? Is there a feature maybe that you didn't discuss to deal with that? Or if not, do you think you might want to put it on the timeline on the roadmap?
Yeah, this is you create a tool, but then there's always potential for misuse. So I don't know if I can eliminate that entirely, although it would be kind of neat, I think, if we could kind of find a way to come up with some like inspections in IntelliJ that could even detect if you're doing some things, at least that are obviously wrong. Ultimately, I mean, it's kind of it's hard to prevent making an error entirely, but there are certain, I guess, best practices that you could use that would make it easier to get it right, like maybe using a zone date time or something, or not assuming 24 hours for a day length.
I was fond of the Android time object that had a parameter for ignoring or respecting daylight savings. But they deprecated that, and I haven't seen anything else with similar features. I thought I would ask. It was really irksome. And I had to return it an hour earlier. I was completely messed up that day.
Doing date and time arithmetic is very hard. You can do it in 100 different ways, and every way could be valid, but wrong for your particular situation. It's really hard to do right. And even with your great library, it's going to, people still have to use it correctly to get the right outputs.
Very true. I mean, even simple things that can trip you up. Like if you made an assumption that midnight is the start of the day, it's actually not, because some places actually can change from standard time to daylight savings at midnight, like in, I think, Brazil. So so midnight to 1 a.m. doesn't exist. So 1 a.m. is actually the start of the day if you're looking at it.
Hey Eric, can you hear me? This is Aaron.
Yep, I can hear you.
I had a question. Did you work on this alone, or did you work with other people? And part of that is, do you plan on continuing to work on it, or is it just like something that you're going to set aside? What do you think?
I've invested too much in it, just put it aside. But I have worked on it basically all on my own, which is, I actually would really like to have additional collaborators. If people were willing to help out, that'd be awesome. But it's been kind of a hobby project, really.
Cool. Yeah, it's good to hear they're going to keep working on it.
Stop working on and supporting it, though.
Great.
Any other questions or?
There was a slide a little while back about type conversions. There was one type that supported like a componentizing or something, and you said, how do you do that conversion?
That's actually for it's for iOS. I think is one you're talking about.
Yeah, I meant to like type into the chat, but it was a few slides back, and I just remember your commenting.
Actually,
other types couldn't do something, but you could convert them, and I wasn't sure if you wanted to comment on how that conversion would go.
I guess I'm not quite following. Let's see here. There, from here or from?
I thought it was a little bit forward from there. No. Yeah, that. Okay, yeah, that's it.
Yeah, okay. That's on
Apple type. Okay.
Yeah, so on Apple you have, oops, I accidentally went forward. So on Apple you have their design is a little bit different for their library. They don't have like the same array of different structures that you have with the newer Java time library. So the newer Java time library tries to be very, I guess, type safe. So they have a separate like local date time, offset date time, zone date time, and you don't really have exact equivalents for all of those on iOS. You have this date components object that can kind of do all of them. It can even be a duration if you want, which is a little confusing. So it's kind of a very multi-purpose kind of data structure. So you have to, it just means you have to kind of be aware of the fact that it's kind of just a container that can have a whole bunch of different things in it in any kind of form, and it's up to you to like verify that it's the form that you want if you're like manipulating it. I don't know if that makes sense.
Yeah, it does. It's good. Will you be sharing the slides?
I can, yeah, if you'd like.
That'd be great.
We also recorded this session, so we can. It will be on our YouTube channel in a few days.
Oh boy.
You're going to be a rock star.
Hey Eric, this is me again. I just had another kind of general question for you.
Mm-hmm.
Is this your first, I guess, open source or like a library that you've built? And if it is, like, what was your experience working on this?
Not my first. I wrote a couple other TypeScript libraries, this is probably definitely the biggest project that I've kind of undertaken, I think, on my own though.
Was there anything that like stood out to you, like things you would have done, or like I guess what was like your biggest challenge you think as you were working on this? For someone who might want to like do their own multi-platform library.
I guess time and wanting to do too much. You got to stay focused on what you want to kind of get done. And I definitely am the kind of person who almost like can tend towards to like OCD like detail about aspects of something or the API, and sometimes you have to know when to kind of keep that sort of thing in check so that you don't spend too much time working on something like this.
Cool.
Trying to find a balance, and ideally getting other people to help collaborate on something like that would be really really good too. I hadn't really had any kind of big takers who wanted to like dive in and help me out with this. If anyone had, I'd say that'd be fantastic. I'd love the chance to do that, because it could take a little bit of the burden off me. And ultimately, if this is a library that people want to actually make use of, you want it to live on and use in production, it kind of needs to have a lot more community involvement in order to back it. So I mean, getting any kind of community involvement like that would be really important. Or direct JetBrains involvement if they had interest. That'd be great too. But ultimately, it needs some other kind of involvement like that in order to make it something that's I guess really sustainable.
Okay. So if I wanted to in the future or like soon, just maybe help out a little bit, do you have something like on GitHub that some issues that I could look at or something like that?
Yeah, there are some issues that are there. They're could be a lot more. There's never a shortage of things that can be improved on. There are a lot of things that can be improved on with this. So I mean, that'd probably be a good exercise for me to go write up some more things just to see if the kinds of things people might want to help on. Yeah, I mean the GitHub page is in the link on the last slide.
Thanks. I'll check it out.